Okay, thank you everyone. So good afternoon, everyone. Thank you very much to join this session. I'm very glad to be here to meet all of you together. So I am Lisa Li. I am from the trade desk based on Shanghai, China office. Yeah. So in fact, the trade desk is not a pure data storage company. So here, for those who are not familiar with the trade desk, let me give you a simple introduction. Okay, so when you are surfing on the internet, some advertisements are served to you. Most of the time, such ads are very related to your life. Do you know why? Because we do the real-time bidding in the backend. Okay, so when you open a web page, the publisher sends a request to supply-side platforms, which will start an auction. And then such request will be sent to demand-side platforms, which are short for DSP. So in a DSP, it does calculation based on the request and the configuration created by advertisers. And then it finds out the most relevant ads and send back a bid request to join this auction. So once it wins, it will show the ads to you. Okay, so all of the process happens in about a tenth of a second. Yeah, so the trade desk is a DSP company which has built on powerful programmatic platform to help advertisers to buy ads, to reach more people in more places with the best-in-class transparency and return on investment. Yeah. So here we are here. Okay, yeah. So about the agenda today. So this is a hands-on session. So at first, I will explain why we need to do such investigation, and then I will explain how a SQL query is executed. And finally, I will give you some examples about the optimization. Okay, so the team I worked on at the trade desk focuses on the business related to retail. Okay, so we help merchants to increase their business and meanwhile help advertisers to post more effective ads. Okay, so one of the features I ever worked on is item sales events for targeting and measurement. So merchants like Woolies, they upload their product catalog information to our platform and then share such information with brand advertisers like P&G. Okay, and then through sharing data by merchants, the brand advertisers could do product level targeting and measurements. Yeah. So why I gave such an introduction? Because I use some of the example tables in the later examples. Okay. So here is the small piece of them. We use SQL Server to manage our database, our metadata. So there are three tables we will use later. The first one is merchant. So it's to store the merchant information. And the second one is merchant product. So it is to store the product information which are provided by merchants. So this table will be mainly used in the later examples. So let me give more introduction. So we have source product ID. So this is a unique identifier in the merchant side. And the merchant ID, just the ID of a merchant. And the product ID is the primary key in our system. Okay? And then the last table is advertiser product. So as I said, the merchants share product to brand advertisers. So this table is to record the permission information. So which products an advertiser could access given a merchant. Yeah. So here is some example data. Okay. So when we first designed this feature, it was designed on the requirements. As time passed, the requirements changed a lot. Meanwhile, the data volume increased a lot. So in our case, the number of products, like the number of records in the merchant product table increased from about 2 million to 20 millions, 24 millions. Okay, and meanwhile, because different merchants have different number of products, we have some unbalanced issues. Okay, so as a result, we have encountered some timeout issues when doing SQL queries. Okay, I think this is the common case for most features which use SQL to maintain their metadata. Okay, so before you reach out a database administrator, do you want to try to solve the problem by yourself? Yeah, so I think today, I hope I could give you some hints. Okay, so let's start. We need to understand how a SQL query is executed before we do any optimization, right? So we need to understand what indexes are. So in fact, indexes are separate data structures. They are in order and they are built on one or multiple columns, right? So they are used to accelerate the retrieval of data. Okay, so with these separate data structures, you don't need to scan all the records in the table. So it could decrease the disk IOs. But please also note that you need to update the related index if you update any data in the data pages, in the data table. Okay, yeah. So most of the time, we use B-tree to store an index. So B-tree is a self-balanced tree data structure. It is used to query data. So the main point is that all the leaf nodes are at the same level. As a result, the time complexity to query a data is much similar. That is O log n. Okay, so based on the different criteria, we could have different kinds of indexes. So for example, based on the storage, we could have clustered and non-clustered indexes. And based on how many columns are used, it could be a single index or a composite index. Let me give more description in the next page. So here I gave 2 examples about them. So as you know, the SQL Server is a role-based database. All the records are stored in blocks, which are called data pages, right? So a data page could contain multiple rows. So look at the red chart. I still use the merchant product table as the example. So it is the primary key is product ID. All the data are ordered by product ID. And then if an index is created on this column, you may notice that we have several long leaf nodes created. Okay, so please notice that the leaf nodes are the record rows on the data pages. And in the other side, if this table is not ordered by product ID, maybe it's ordered by some other columns or not ordered. So if we are going to create an index based on the product ID column, you may notice that in the second column, it contains all the leaf nodes, and each leaf node points to the row in the data pages. Okay, so this is a long cluster index. Okay, so as a result, we could create at most one clustered index on a table or view, but could create more than one non-clustered indexes. Okay, so based on how many columns are used. We could have single and composite index. So look at the left chart. It's simple. The index, an index is created on the product ID column. Okay, so it's much simpler. So if you want to query some data based on the product ID, it just navigate the B tree to find the record. Okay, so in the other side, we could create an index based on multiple columns. For example, based on the merchant ID and the source product ID. Okay, so with this case, if you are going to query some products based on the filter merchant ID or based on the filter merchant ID and source product ID, it's feasible to use such an index, but you couldn't query with the filter just source product ID for this index. Okay. So once we understand the execution plans, let's check how a SQL query is executed in the database. So an execution plan is the sequence of steps that the database executes a SQL query. So you could run the SQL query in the Management Studio tool, and meanwhile you label the execution plan, and then you could check. Yeah, you could check it. Okay. So here we mainly focus on the following basic metrics: the operation. So which operation is used in the query? I will give more detailed information in next page. Number of rows read means how many rows to read. Predicate, this is the filter part. Which columns are used as the filter? Object normally is the index, and the output list are the return columns. I hope you could see the chart. Okay, yeah. And about the operations, here I list the 3 main operations. The first is index seek. So database, when you query some records, the database navigates from the root of the index until the leaf nodes to find out the data. That is an index seek. And index scan, if there is no index to use, the database needs to scan all the data in a table or view to find out the records which satisfy the filter part. And the last one is K-lookup. Database performs lookup when the database did an index seek at first, but the index part doesn't include all the required columns. So as a result, it leads to go back to the data pages to find out the additional columns. So most of the time, if a SQL query doesn't return all the data in a table of view, the performance of index seek is better than performance of index scan, and is better than the performance of K-lookup. Okay, so in the next part, I will give you some examples about optimization. So the first example is about the case with or without indexes. The query, we still use the merchant product as an example. The query is very simple. It uses the merchant ID and the source product ID as a filter to find out the related product information. So in this part, it finds the product ID at first and then does a K-lookup. So let's focus on the part to find out the product ID at first. So here I list the detailed matrix information in the right. 2 cases. The first case, I didn't create any index. So the operation is index scan, and the rows to read is 30,024. So I use an example database. So the total records in that database is 30,024. And in the predicated part, that's okay. So and then in the right part, I created an index under merchant ID and source product ID columns, and then run the query. The operation is index seek, and the number of rows read is 1. So it means it uses the index to do search. It just navigates from the root until the leaf node to find out the result. And then the second example is about whether an index is used correctly. In the merchant product table, we have a column called source product ID. If we set the type of source product ID as varchar type, and I need to do some query, the two queries have the same result. So it queried by merchant ID and a list of source product ID to find out the related products. Okay, so in the first query, in the two query, I created a temporary table and stored the source product ID list in the temporary table, right? So in the first part, I set the type of the temporary table as varchar, which is the same as the type in the merchant product table. And then in the second query, I set the volume type as nvarchar, which is different, okay? So when I run the two queries, we have different metrics. The left part, the left chart shows the matrix with the same type. So the operation is index seek, and the number of rows read is 4. And the predicates part, it uses the filter, the merchant ID and the source product ID to do the filter. Okay, and then in the right part, the operation is still index seek, but the number of rows read is 24. Okay, and the predicates part, it uses the merchant ID as the filter. What does that mean? Okay, so both the two queries use the composite index to do query, right? But in the second case, it just uses merchant ID to do search at first, and then it scans all the records for this merchant ID, for this merchant. Okay, why did this happen? Because the type, when it does the query, the database can't convert the type from nvarchar to varchar implicitly. So most of the time, we use some language to generate a SQL query automatically, right? For example, you may use C# entity framework, right? So such query, you need to pay attention to such queries, because it normally choose the nvarchar for a string. Yeah, so you need to make sure the indexes you create work as expected. Okay, and then the second example is about an index view. So sometimes we need to do a query to scan all the records in a table or view to get some aggregated data. So in this case, we need to find out the number of products each advertiser could access per merchant. So here is the detailed matrix. It does a clustered index scan, and then the number of rows read is 30,024. Okay, so sometimes it increases a high workload in the database. So what can I do? we could use an index view to solve some problem to decrease this situation. So different from a normal view, an index view stores data on the disk, and meanwhile it creates an index on the view. Okay, so here I created an index view with this SQL query, and meanwhile create an index on the merchant ID and the advertiser ID columns. Okay, so it does a clustered index scan, and meanwhile the number of rows read is 12 because we have 12 entries in this view. Okay, yeah, so that's all the examples, and let me give you a summary here. So if you use SQL or relational database to manage your metadata, please create necessary indexes to improve the query performance. And meanwhile, once an index is created, please make sure that index works as expected. And finally, if you are going to do some aggregation, need to scan all the table to do some aggregation, you may use an indexed view to accelerate the query. Okay, yeah. So in fact, that's all the content today. Thank you very much for joining this session. In fact, in our company, we have different kinds of data to handle. SQL Server just a small piece of them. We also have some other kinds of data, key-value database or column-based database, and some other technologies. I think this is just a start for the trade desk to introduce the technology or problem or issues we are using. I think we will have more topics in the future. Thank you very much.